Hello everybody, we're doing example number 2. It says solving an initial value problem. I will abbreviate these as an IVP. Okay, so what we're basically going to do is we're going to take our general solution and then we're going to find some specific one of those, which one of those slope fields are we looking for, if you looked at the previous video. And in this case it says find the particular solution to the equation dy dx equals e to the x minus 6x squared whose graph passes through the point 1, 0. And we're going to written out the problem over here. I'm going to go ahead and do this one out right now for us. Okay. Ooh, sorry. Alright, so what we need to do is first, when you want the particular solution, that means that C is going to be some number. It means that C is going to be, we're going to find that actual number here. And so first we need to find the general solution, and then we're going to find the particular solution to that. So I'm going to rewrite my equation dy dx equals e to the x minus 6x squared. Okay. Now what I'm going to do is I'm going to multiply by dx to both sides, because before we anti-differentiate, we need to make sure that our d's and our y's are on the same side. So I get dy equals e to the x minus 6x squared times dx. And now I'm going to apply, or we're going to anti-differentiate both sides basically. I'm going to put the integral there. The indefinite integral, the integral of dy, or 1 dy, is just y. And then what we get here, the antiderivative of e to the x is e to the x, minus the antiderivative of 6x squared. If you remember, you add 1, and we multiply by the reciprocal of that, so it's going to be minus 6 times the reciprocal of, this is going to be 3, so it's times 1/3 x to the third, and then we're going to put plus c. Remember, we need this plus c when you're taking the indefinite integral. You get the plus c, so then this is going to give us our general solution. So we get y equals e to the x. It gives me minus 2x cubed plus c. So now let's be clear here. I'm not going to box this in, but I will make a comment and a note here. This is the general solution. That's not what I'm after, but it is. This will help me find the particular. So for the particular, what you want to do is plug in the initial value. In other words, the initial value that they gave us, if you look at the problem, the initial value was here, because it goes through this point here. So this is my initial value, is this point here, 1, 0 here. So we're going to go back here now, and we're going to say, okay, so I know I have my general solution here. Right, that looks straight, right? Doing this on a corner, kind of. So I know that my initial value is 1, 0, right? And what this means is this is x and this is y. So basically you're going to plug 1 in for x and 0 in for y and then solve for c. I'm going to do this down here. So I'm going to get here. So we know that y equals e to the x minus 2x cubed plus c. And we know that x is 1. So e to the 1 minus 2 times 1 cubed plus c. And y is 0. Now all I got to do is solve for c. And we're back to algebra 1. And we have 0 equals e to the 1 is e minus 2 times 1 cubed is 2 plus c. I'm going to minus e and plus 2 to both sides. These go away. And I'm left with c is equal to negative e plus 2 here. Okay, so this is my initial value. And now I know what c is. This is c here. So I'm going to take this guy and plug him back over here. And so my final answer is going to be... So no, we found the general. Now this is the particular. So I'm going to find the particular solution. Okay, is y equals e to the x minus 2x cubed plus c. Now remember, what was c? C was what? Negative e plus 2. So I'm going to put plus 2 minus e. Is that okay? That's basically the same thing. And if you check, or this is my final answer here, right? And this is what they got over here in the solution. Okay, just to verify what the heck is going on in your calculator, I want to show you here. I've already graphed out, and here I have the one of the particular solutions to this one. In this case, c is 0, right? So if I were to graph this out, Let me graph it out here, right? It looks like this. So something like this. Now this is just one of them, right? So what happens is when you graph a slope field, you're not graphing one of them. You're graphing all of these different equations here. So I just wanted to give an example. Over here, I'm pasting the same equation. All I'm doing is I'm slightly modifying the value of c. So I'm just rewriting the same equation with different values of c added on. And our one value that was true, which was it was e. Let me put this here. E, so 1, and this was plus 2. It was actually minus here. Okay, so I'm going to graph all of these now. So you can see there's another one and another one there. It's being built on top of it, and there's the last one here, right? So they're all pretty close together. You can't even see them. They're so different. But they all get in there, right? So what happens is when you find your particular solution, what you're telling graphically what you're basically saying is you're saying, okay, so hey, look, I found the one I wanted. So all of these others are gone, and all I care about is this guy here, which was the final answer. So when I graph it here, so then this is actually the final answer here. Even though it looks identical to the other one, it's still a little different here. We're going to practice doing this more in the other examples as well, but this is how you would do the next set of problems here.